Hey guys, if you remember in 2014, there was a blockbuster film directed by Christopher Nolan, Interstellar. In this film, space related concepts such as wormholes, black holes, alien planets were depicted in a scientifically accurate way. But perhaps the most shocking scene was at the end of the film when, in the climax, the main character of the film, Cooper, falls into a black hole. In the film, the name of the black hole was Gargantua. Cooper falls into a black hole with his spacecraft. Initially, everything was black all around him, complete darkness. But as he falls deeper, he notices some green like particles. These particles hit his spacecraft and cause scratches on it. There were some flashes of light, some sparks, and his spacecraft catches fire. He was forced to eject from his spacecraft and he kept falling into the black hole, and suddenly he found himself in a five-dimensional space, a five-dimensional tesseract. It was a mind-boggling experience, a place where he could communicate with his past self by using gravity. Seeing these scenes, you might have wondered if it's actually possible. Does this exist in a black hole? If we fall into a black hole, what will we see? Come, let's try to understand these aspects in today's video.
Black holes remained largely unknown until the 20th century. A black hole is a region in space where the force of gravity is so strong not even light can escape.
From the outside, you can't tell what is inside a black hole.
Black holes haunt our universe, dark centers of gravity that swallow everything in their path.
Let's begin with the beginning of the story, friends. The history of black holes isn't very long. 100 years ago, no one knew about black holes. Because of Einstein's theory of relativity, black holes were later discovered. Friends, there are two parts to this theory: the special theory of relativity and the general theory of relativity. The special theory of relativity, published by Einstein in 1905, tells us how speed influences time. If you're in a spaceship that is going very fast, if the speed is too high, time will slow down for you. Relative to the people on the spaceship back on Earth, the word relative is very important because when you are on the spaceship, you wouldn't feel the time slowing down. You would think that time is flowing at the same speed as it normally does. But when you'll get back to Earth, you'll find out there was a difference in the flow of time. This is known as kinematic time dilation. Not only is speed, but even gravity can also result in time dilation, as shown by Einstein in his general theory of relativity. This was developed by him in 1915. The more gravitational force you would experience, the more time would slow down for you. This is known as gravitational time dilation, and this was depicted amazingly in Interstellar. When Cooper and his team land on the Aqua planet, 1 hour on that planet equals 7 years on Earth. This happens on the planet because the planet was very close to the Gargantua black hole, so the gravitational force of the black hole impacted the time. To visualize this, Einstein wanted us to imagine a space time fabric, kind of like a mesh, on which all planetary objects are placed. The space time fabric bends due to the mass of the objects, and when the mesh bends, not only does it attract physical objects more, but it leads to the time dilation as well. And the other forms of energy, such as sound, heat, or light, they are affected by gravitation as well. Yeah, that's right. This was another conclusion drawn by Einstein. Gravitation affects almost everything. Not only are physical objects attracted by the force of attraction, it attracts heat, sound, and light as well. Friends, this means that there can be such objects in the universe which have such a high gravitational force that they can completely absorb light. If they are such objects, it's mean that they would be completely black. We won't be able to see them because not even light can speak them. Friends, this is exactly what black holes are. After Einstein, the theory of general relativity was worked on by many scientists. There were several equations. They solved those equations and tried to derive the solutions. And by getting to the solution of these equations, it was theoretically proven that things like black holes do indeed exist. By the 90s, researchers and scientists had finally agreed that not only theoretically, perhaps one day, realistically, we'll be able to see black hole because these do exist in space. The term black hole was used for the first time by a magazine in 1964, but only after 1967 did the term gain popularity when physicist John Wheeler popularized it. Even though the black hole term sounds quite sensational, it is a misleading name. Black hole. It might sound like there's an actual hole there, but that's not the case. There is no hole in the space. Black holes are formed by stars, so there is some material at its center. But in the stars, even our sun is a star, there's a continuous nuclear fusion reaction at their center. These reactions produce heat and light. The heat being produced sends a force outwards, and at the center of the star, there is a force of gravity that helps the star remain intact and alive. This is how the stars maintain equilibrium throughout their lives. The forces pushing outwards due to the reaction and the forces pulling inwards to the gravity, but these reactions take place when a fuel exists, either hydrogen or helium. The fuel wouldn't always be there, it would get burned up at some point. And when the fuel ends, there wouldn't be any forces pushing outwards, and the gravitational force pulling inwards wouldn't be countered by an equal force, so that the star will collapse on itself because of its own gravity. This will take a long time. Let's look at the chart of the life cycle of a star. If the mass of the star isn't high, if it was a small or average sized star, it turns into a red giant, after which it can become a planetary nebula or a white dwarf. But if it was a star with a lot of mass, when it runs out of fuel, it cools down and turns into a red supergiant. And then supergiant bursts and turns into a supernova. After this, a tiny core remains. If the core is tiny, it is called a neutron star, but anything bigger than that, we'll call it a black hole. Now that you've understood why black holes exist, now let's understand how black holes are. There are mainly three till four types of black holes. The first is a stellar black hole. That is the most common type of black hole, the black holes that were created by stars. Scientists estimate that in our Milky Way galaxy, there are anywhere between 10 million to 1 billion such black holes. Number two, then there are primordial black holes. Their size is as small as an atom, but their mass is like of a mountain. There is an assumption about that they are as small as an atom. Friends, these black holes are merely theoretical, hypothetical. We do not know much about these. The third type of black hole is a supermassive black hole. These black holes are enormous, so big that their mass is more than that of 1 million suns combined. Can you imagine? And it fits into a ball whose diameter is as big as that of our solar system. Scientists believe that at the center of every major galaxy, there is a supermassive black hole. The supermassive black hole at the center of our Milky Way galaxy is called Sagittarius. And the black hole in the film Interstellar that was named Gargantua was said to be a supermassive black hole. Additionally, scientists believe that there may be a fourth type of black hole too, though it cannot be said for sure. The fourth type of black hole will be intermediate black hole. The fall down inside the black hole. What will be the center of the black hole? Einstein's general theory of relativity tries to describe this. In this theory, the center of black hole is termed singularity. Singularity is the region of a black hole, the center where the curvature of space-time is infinite. Do you recall that mesh that I talked about in the first half video? The heavier the object, the more the mesh of the space-time will bend. In the case of the black hole, this is bent so much that it stretches infinitely. And as we know from the theory of relativity, time, energy, and everything else is affected by gravity. With the increase in the gravitational force, times keep getting slower infinitely. But what does it mean for the time to get slower infinitely? Does this mean that if you go inside a black hole and if you could ever get out of it, the universe outside would have ended for the rest of us? We do not know. We can only make theories. What do you think? Comment below and let me know.